I hope you remember from general chemistry that one way we can measure the work done by a chemical system is to take the pressure at which the work is being done and multiply it by the change in volume of our chemical system, or work is equal to P delta V. And this is true also of heat engines, that we can look at the work done by our heat engine as the pressure at which we're working times the change in volume, which we just looked at with our indicator diagram. Now, one way we can increase the efficiency of a high-pressure steam engine is to work the steam engine expansively. And this is a very important concept when we come to understand the Carnot cycle. So let's first look at how this works in the real world. Again, this is an invention that would have come around in the early 1800s as high-pressure engines were being developed. So how does a locomotive engineer, for instance, work steam expansively? Well, let's begin with our indicator diagram and with the throttle of our engine open and with steam being admitted into the cylinder. Now again, the pressure is constant because the steam coming off of the boiler is at a constant pressure. The piston is moving, and the volume of the cylinder, and again, we're only looking at this half of the cylinder now, the volume of the cylinder is increasing. Now, at about halfway down the length of the piston travel, we're going to shut off the steam. No more fresh steam is going to be admitted into our cylinder. And what happens now is the energy of the steam expands, because the energy of the steam causes it to expand, the energy of the steam causes it to continue to expand. And as it continues to expand, the pressure drops. The volume increases because our piston is moving, but the pressure of our steam is dropping even as the steam continues to do work by pushing against the piston. Now, at the end of the piston stroke, we are going to open up the valve to the atmosphere. So again, pressure is going to be the same. Pressure is going to be constant because we're opening this valve to the atmosphere. We're allowing steam now onto the other side of the piston, and we're pushing the piston. So the volume on this side of the piston, the volume is decreasing and the pressure is staying the same. Finally, at the very end of the piston stroke, we are allowing fresh steam into the cylinder. We've once again opened up our valve. The volume is not really changing because the piston is at the end of its stroke. The pressure is rising rapidly. And again, what we're going to have happen is about halfway through the piston stroke, we're going to cut off the supply of steam, and the steam is going to expand because of its internal energy. Now, this is going to cause the heat or the temperature of the steam to drop. It's going to cause the pressure of the steam to drop, and but the steam is going to continue to do work. This was a very important development in the development of heat engines, or in the history of heat engines, because it allowed us to get more work from the same quantity of steam. If you think about a train starting up and rolling, it takes a lot of energy to get the train rolling. Once the train is moving, it doesn't require quite as much energy. So by working the steam expansively, by setting a cutoff, we can keep the train moving without having to feed fresh steam into the cylinder throughout the entire length of the piston stroke. And again, this is something that's going to dramatically increase the efficiency of a heat engine. And how that's going to fit into Sadi Carnot's thinking on the subject, we're going to talk about in an upcoming video.